Megacorp's Windows reporting team needs a shared drive, so the instinct is to grab the managed file system you already know. But that service only speaks NFS to Linux. Their tools speak SMB, tied to Active Directory. Reach for the familiar answer here, and it simply will not mount. Stack lessons, Cloud Architect path. Let's work. By the end of this video, you'll be able to read a file storage scenario, spot the keyword, and pick the right Amazon FSx file system in seconds. There are 4 of them, each built for a different world, and one classic wrong turn where people substitute the wrong service entirely. That distinction shows up directly in design high-performing architecture scenarios. In the last episode, we covered EFS, Elastic Serverless NFS, that thousands of Linux clients can mount across multiple zones. And we covered EBS, single instance block storage inside one zone. Both are great, but both assume you're speaking NFS on Linux. Now we go past that. Windows shares over SMB, blistering parallel throughput for machine learning, and enterprise storage that speaks several protocols at once. 5 terms will carry this whole video. SMB is the protocol Windows uses for file shares, and it goes hand in hand with NTFS permissions and Active Directory logins. Lustre is an open-source parallel file system for high-performance computing. Think raw speed across many nodes. NetApp ONTAP is NetApp's enterprise storage system, and its SnapMirror feature replicates data for migration and disaster recovery. OpenZFS is an open-source file system accessed over NFS. It works with Linux, Windows, and macOS, though its primary home is Linux and ZFS migration workloads. And finally, Scratch versus persistent is the choice you make when you deploy Lustre. One is throwaway, the other survives. Here's the problem. Not every workload speaks NFS on Linux. Megacorp's Windows reporting tools need SMB shares with Active Directory authentication baked in. If they ever run machine learning training or scientific computing, they'll need parallel throughput that a general-purpose share can't touch. And an enterprise migrating off a NetApp array needs NFS, SMB, and block storage all in the same system. One managed file system can't be all of those things well. So Amazon Web Services built a different one for each ecosystem. That family is called Amazon FSx. Think of picking an FSx variant like picking the right vehicle for a job. FSx for Windows File Server is the company minivan, practical, reliable, and every Windows user already knows how to drive it. FSx for Lustre is the Formula One car, the fastest thing on the road, purpose-built for one job. FSx for NetApp ONTAP is the Swiss Army truck. It goes anywhere and speaks every protocol. And FSx for OpenZFS is the precision sports car for Linux engineers who grew up on ZFS. 4 specialists, and here's the shared foundation. All 4 are fully managed. Amazon Web Services handles the hardware, the patching, the backups, and the failover. You just bring your data. Let's start with the Windows one. FSx for Windows File Server is a fully managed natively Windows file system. It speaks SMB versions 2.0 through 3.1.1 with real NTFS permissions on top. It joins Active Directory, either Amazon Web Services managed or your own on-premises domain, so your existing groups and access rules carry straight over. You also get DFS namespaces, so existing network paths keep working, shadow copies for end-user file restore, and user quotas. And for availability, you choose single AZ to save money, or multi-AZ, which keeps a standby file server in a second zone and fails over automatically. The Amazon Web Services documentation frames it as a lift and shift service. It provides fully managed Microsoft Windows file servers backed by a fully native Windows file system with the compatibility to move enterprise applications to Amazon Web Services with no changes. That phrase matters. A bank running Windows file shares on-premises can join this to their existing domain, keep their NTFS permissions exactly as they are, and their applications never notice the move. Zero replatforming. Here's the mental model. FSX for Windows File Server is like hiring a Windows administrator who never sleeps. They've already stood up the shared drive, joined it to Active Directory, configured the access controls, and turned on shadow copies. You just map a network drive and start working. There's no server to patch and no domain configuration to troubleshoot. Now the mistake that costs people the most. When a scenario says shared file system, the reflex is to reach for EFS. It's elastic, managed, and cheap. But look at the two side by side. EFS speaks only NFS to Linux clients. No SMB, ever. No Active Directory for file authentication. FSX for Windows speaks SMB, serves Windows clients natively, enforces NTFS permissions, and integrates with Active Directory. Choosing EFS for a Windows SMB workload is like showing up to an iPhone convention with an Android charger. Both are chargers, both plug into the wall, and neither one fits the port in front of you. So burn this decision rule in. The moment a scenario mentions SMB, NTFS permissions, or Active Directory file access, the answer is FSX for Windows File Server. EFS is wrong for those, no matter how many other correct-sounding properties the question gives it. And the reverse holds too. EFS is right only when the scenario explicitly wants elastic, serverless NFS for Linux. Now the Formula One car. FSX for Lustre is a managed version of the open-source Lustre parallel file system, the same technology that runs some of the world's fastest supercomputers. It's POSIX compliant and Linux native, and the numbers are extreme. Sub-millisecond latency, millions of IOPS, and throughput measured in terabytes per second. It's purpose-built for machine learning training, scientific computing, video processing, and financial modeling. And it plugs straight into SageMaker, Amazon Web Services Parallel Cluster, and Amazon Web Services Batch, so your training and compute jobs read from it directly. The Amazon Web Services docs give you the keyword list almost verbatim. You use Lustre for workloads where speed matters: machine learning, high-performance computing, video processing, and financial modeling. Those are exactly the trigger words a scenario will hand you. When you see any of them next to a demand for parallel, high-throughput shared storage, Lustre is the answer. The Lustre plus S3 pattern is the one you'll see again and again. Think of S3 as a massive, cheap warehouse where your raw data lives. FSX for Lustre is the high-speed loading dock right next to your factory floor. You don't copy the whole warehouse to the dock up front. You link Lustre to the S3 bucket, and only the metadata comes across immediately. The actual file contents get pulled from S3 on first access. That's lazy loading. Your compute nodes then read at Lustre speeds, and when the job's done, results export automatically back to S3. Because nothing copies up front, a Lustre file system linked to a 1 petabyte bucket comes up in minutes, not hours. When you deploy Lustre, you pick Scratch or Persistent, and there's a clean way to remember the difference. Scratch is a whiteboard in a conference room, blazing fast to write on, but you wipe it clean when the meeting ends. Scratch isn't replicated, so if a file server fails, the data is gone. That's fine when your source data lives in S3 and can be reloaded. Persistent is a notebook, still fast, but your work survives because data is replicated within the zone and failed servers get replaced. Reach for Scratch on short, reproducible jobs where cost matters. Reach for persistent when durability matters, or when an iterative training run has to keep its intermediate results between passes. And here it is, straight from the documentation, in case a question tries to muddy it. Scratch file systems are ideal for temporary storage. Data is not replicated and does not persist if a file server fails. Persistent file systems are ideal for longer-term storage. Data is replicated, and file servers are replaced if they fail. If a scenario stresses reproducible data and low cost, that's Scratch. If it stresses durability or a multi-day workflow, that's persistent. Quick halfway check, because these first two are the heavily tested pair. Windows SMB, Active Directory, or NTFS points you to FSX for Windows File Server. High-performance computing, machine learning, parallel, or high-throughput points you to FSX for Lustre. Lock those two in and you've handled most of what the exam asks here. Two variants remain, the multi-protocol one for NetApp shops and the ZFS one for Linux teams. Let's cover both. FSX for NetApp ONTAP is the Swiss Army truck. Its headline trick is multi-protocol access. It serves NFS, SMB, and ISCSI block storage all at once on the same file system. It's the only FSX variant that speaks ISCSI, and it also handles NVMe over TCP. On top of that, it brings NetApp's SnapMirror replication, both within a region and across regions for hybrid setups and disaster recovery. Who reaches for this? Enterprises that already run NetApp on premises. They use SnapMirror to replicate straight into Amazon Web Services, and because ONTAP speaks every protocol, their Linux apps, Windows desktops, and databases all migrate with no changes. The documentation lists the protocols plainly. Multi-protocol access using the network file system, server message block, ISCSI, and NVMe. That combination is the single most important fact about ONTAP. No other Amazon Web Services file service serves NFS, SMB, and block storage on one system at the same time. When a scenario needs all of them together, this is it. In practice, the real trigger for ONTAP is a sentence like this. We already run NetApp on premises, and we want to use SnapMirror to move to the cloud. The moment you see NetApp, SnapMirror, or a requirement for NFS, SMB, and ISCSI on one system, ONTAP is almost certainly the answer. A manufacturing company with Linux apps on NFS, Windows users on SMB, and an Oracle database on ISCS, I can migrate all three with no replatforming at all. Last one, the ZFS sports car. FSX for OpenZFS is built on the open source OpenZFS file system and accessed over NFS, versions 3 through 4.2. It works with Linux, Windows, and Mac OS compute instances, though its primary use case is teams migrating Linux or ZFS workloads from on-premises. It's seriously fast, up to 2 million IOPS, with latencies of just hundreds of microseconds. Its signature features are near-instant snapshots and space-efficient copy-on-write clones. Teams already running ZFS on premises get identical semantics in the cloud, same snapshots, same clones, same permissions, with essentially zero learning curve. The Amazon Web Services documentation positions OpenZFS as the migration path. It makes it easy to move data to Amazon Web Services from on-premises ZFS or other Linux-based file servers without changing your application code or how you manage data. So when a scenario says on-premises ZFS or migrating off a Linux file server without touching the application, OpenZFS is the intended answer. And note carefully, it's NFS only. It does not do SMB or Windows. There's one OpenZFS pattern worth knowing because it makes for great scenario questions. Picture a 10 terabyte production database on OpenZFS. Using instant clones, every developer gets their own writable copy of the full dataset in seconds. The clone used copy on write, so they share the underlying blocks with the original. You're not paying for 10 terabytes times the number of developers. Only the changed blocks consume extra storage. When a developer's done, they delete the clone. That snapshot, clone, test, delete cycle replaces a slow, hours-long process of copying data for every single test environment. If a scenario mentions fast, isolated test copies of a large dataset, think OpenZFS clones. Here's the whole thing on one screen, the map that makes these questions fast. Windows, SMB, Active Directory, NTFS or DFS goes to FSX for Windows File Server. High performance computing, machine learning training, parallel or high throughput goes to FSX for Lustre. Multi-protocol, NetApp, SnapMirror or NFS plus SMB plus ISCSI goes to FSX for NetApp ONTAP. ZFS, Linux low-latency NFS, instant clones, or ZFS migration goes to FSX for OpenZFS. And the fifth line is the one people forget. Elastic, serverless NFS with auto-scaling and no capacity planning is Amazon EFS, not FSX at all. One more angle, because protocol is often the deciding word. Only two services speak SMB, FSX for Windows File Server, which is your Windows answer, and FSX for NetApp ONTAP, which offers SMB alongside NFS and ISCSI. EFS and OpenZFS never do SMB. On the NFS side for Linux, OpenZFS gives you low latency ZFS. EFS gives you elastic serverless scaling. Lustre gives you parallel POSIX for computing. And ONTAP serves NFS too. So if a question hinges on the word SMB, your candidates shrink to just Windows and ONTAP immediately. One quick lifecycle note so you don't get pulled toward a stale answer. FS File Gateway, the old storage gateway product that cached Windows shares on premises, was restricted to new customers back in October 2024. You can't build new architectures on it. If a scenario needs local caching for on-premises access, the modern answer is connecting directly to FSX for Windows, or using FSX for ONTAP with FlexCache. Let's lock it in. Windows, SMB, or Active Directory points to FSX for Windows File Server, not EFS, which lacks Active Directory integration entirely. High-performance computing, machine learning, or parallel throughput means Lustre, where scratch deployments are disposable and persistent deployments survive a file system restart. Multi-protocol needs or NetApp migration means ONTAP, the only FSX variant that speaks ASCSI alongside NFS and SMB. And ZFS, or Linux low-latency NFS, means OpenZFS, while plain elastic serverless NFS means EFS. Match the protocol, match the ecosystem, match the keyword. That's the FSX decision in 3 steps. Now let's see how well that stuck with a quick 5-question quiz. Question 1. A company is moving a Windows application that stores files on a shared drive. It needs SMB access, NTFS, permissions, and authentication through their existing Active Directory. Which service fits? Option A, Amazon EFS with NFS mount targets. Option B, FSX for Windows File Server joined to their Active Directory. Option C, FSX for Lustre linked to an S3 bucket. Or option D, FSX for OpenZFS over NFS. Lock in your answer before I give it away. It has to be B, and here's why. Only FSX for Windows File Server provides native SMB shares with NTFS permissions and Active Directory integration. NTFS and OpenZFS speak only NFS and can't serve Windows SMB clients at all. And Lustre is built for high-performance computing, not Windows file shares. Question 2. A genomics team runs short one-off analysis jobs on FSX for Lustre. The raw data sits durably in S3 and can always be reloaded, and they want the lowest cost for these reproducible runs. Which deployment type fits? Option A, Scratch, because the data is reproducible from S3 and cost is a priority. Option B, Persistent, because all Lustre data must be replicated. Option C, Scratch, because it replicates across zones automatically. Or option D, Persistent, because Scratch can't integrate with S3. Pause here if you want more time. The right call here is A. Scratch is built for temporary reproducible workloads and costs less. It does not replicate data, but that's fine here because the source lives in S3 and can be reloaded. Option C is wrong because Scratch specifically does not replicate, and D is wrong because Scratch integrates with S3 just fine. Question 3. An architect needs a managed shared file system for Windows servers that authenticate users through Active Directory. A teammate suggests EFS because it's elastic and fully managed and cheap. What's the correct assessment? Option A, EFS is fine. Any managed shared file system can serve Windows clients. Option B, EFS, works once you enable its SMB option. Option C, EFS is unsuitable because it's NF only and can't serve SMB or integrate with Active Directory. Or option D, EFS is unsuitable only because it costs more. Think about which constraint matters most here. The answer is C. EFS supports only NFS for Linux and POSIX workloads. It has no SMB option to enable and no Active Directory file authentication under any configuration, so option B's premise is simply false. This is the classic wrong turn. Two managed shared file systems, but only FSX for Windows speaks the Windows protocol. Question 4. A manufacturing company runs an on-premises NetApp array, Linux apps on NFS, Windows desktops on SMB, and Oracle databases on ISCSI. They want to migrate to Amazon Web Services using SnapMirror with no application changes. Which service? Option A, FSX for OpenZFS exposing NFS to everything. Option B, EFS for Linux plus FSX for Windows for the rest. Option C, FSX for Lustre with S3 integration for the database. Or option D, FSX for NetApp ONTAP serving all three protocols at once. Got your pick? Let's see. If you said D, well done. FSX for NetApp ONTAP is the only variant that serves NFS, SMB, and ISCSI on the same system, and it supports SnapMirror for the migration. All three workloads move with zero replatforming. None of the other options can cover IS, CS, INS, MB, and NFS together. Question 5. The full decision map in one go. A dev team wants each engineer to get a fast, writable, isolated copy of a 10 terabyte dataset in seconds without paying for a full copy each time, and they already run ZFS on Linux on premises. Which service fits? Option A, FSX for OpenZFS using instant copy on write clones. Option B, FSX for Windows file server with shadow copies. Option C, EFS with an access point per engineer. Or option D, FSX for Lustre Scratch, 1 per engineer. Run the decision rule from earlier before you answer. This one is A. FSX for OpenZFS gives you near-instant, space-efficient clones where copies share underlying blocks and only the change data costs extra, exactly the ask. And since the team already runs ZFS on Linux, the semantics carry over with no learning curve. The keyword ZFS, instant clones, and Linux all point straight to OpenZFS. And that's a wrap on shared file systems, the Amazon FSx family. Hit subscribe so you catch the rest of the Cloud Architect path and so YouTube shares it with more learners. The comments are where I find out what's working, so tell me what clicked and what tripped you up. Got an exam on your list? Drop it below, and honest notes on the style or pace are always welcome. Catch you soon.